Woohoo! Welcome back. Tonight we're going to be working with logarithmic equations. Yay! The first thing I want to say about logarithmic equations is going to help you on your homework, and that's to make the note that logarithms are also one-to-one, just like exponential expressions are, or exponential functions, which means that if the logarithms are equal, then those arguments, x, so log base a of x equals log base a of y, then x equals y, and vice versa. So that's something you should know, and that might give you a hint on some of the problems in the homework. But we're going to get started on some other problems. Woohoo! Yay! Okay, so let us move into solving logarithmic equations. How do you know it's a logarithmic equation? Well, it's an equation and it has a logarithm. I know, you come to me, this is why they pay me the medium bucks. So, log of x equals 8. So what does that even mean? Well, first thing we need to do is we need to translate. Log with no written base is common log. So that's log base 10 of x equals 8. And of all the ways that we could solve this, I think the easiest way to solve it is to put in exponential form by starting with the base, which is 10, raising it up to 8, and bring it back to x. So in other words, x equals 10 to the 8th, or if you really want to write that out, that's 10 to the 1st, 2nd, 3rd, 4th, pardon me, squirrel, 5th, 6th, 7th, 8th. So that's 100 million. Woohoo! Okay, next problem. Now this one, also one of our special case logarithms, it's natural log. And so I propose that we write this as log base e. You don't have to. But again, I'm going to go ahead and convert it to exponential form by writing it as e, start at the base, go across the equals cubed, equals x minus 1, come back to that, or x minus 1 equals e cubed, and then I just add 1 to both sides, and I get x equals e cubed plus 1. So if you want an approximation, and again, this problem set just said solve, so when a mathematician says solve, this is the answer. You want the exact answer. If you're doing this in WebAssign or another homework, sometimes they want x to the 8th, sometimes they want you to write the whole thing out. You'll have to check to see what format they want. But in this case, this is the exact value, and so that's the most important answer. But then we can also come up with an approximation. And again, just like before, I'll go ahead and work out an approximation to 2 decimal places. Okay, so e cubed. Now this one, it's really hard to see, but above the natural log, you see a little tiny e cubed. So for me to use that, I use my second key. Well, first, I turn it on. Again, this is why they pay me the medium bucks. Hit my second key. Here, I don't know if you guys can see, it says second. And then I'm going to click on the natural log, and I get e to the, and I want to do cubed. Now, the way mine does it, I need to close the parentheses. And what I'll probably do is hit enter to find out that value and then add 1. Just simply do an add 1. And so if I'm going to round that, that would be about 21.09 or so. Woohoo! Okay, let's keep going. This next one, I'm going to have to make use of the laws of logarithms. Remember that when I have 2 different logarithms with the same base, and I'm adding them, then I'm actually multiplying their arguments. I'm multiplying what they're taking the logarithm of. So over on the left side, I get the log of x plus 2 times x minus 1. Addition here gave me multiplication, right? The addition here gives me multiplied here, and that equals to 1. Having done that, the next thing I'm going to do is I'm going to go ahead and, pardon me, move my squirrel. An important part of any math problem, make sure you move your squirrel and it's in a comfortable position. So I'm going to go ahead and now I have a single logarithm instead of 2. And I'm going to convert this to exponential form. And in order to do that, I'll note that logarithm, just plain logarithm, is log base 10. So my exponential form is 10, go across the equals to the first power, equals x plus 2, x minus 1. Yay! So I've done 1 step to get here, 2 steps to get here, and do you all see what we're going to get to do? I know, I can tell you're all very excited. This is a quadratic. Yay! Okay, so 10 equals, I'm going to multiply out x squared minus x plus 2x minus 2. I can go ahead and subtract 10 from both sides. I get 0 equals x squared minus x. Oh, sorry. It's not minus x. Oh my goodness. X squared minus x. Oh, I'll just write it again. I'll combine it less in the next step. And then minus 2 minus 10, so that's negative 12. So I get 0 equals x squared plus x minus 12. Now, does that factor? And the answer is I think it does. What about x plus 4, x minus 3? 4 times negative 3 is negative 12. 4x minus 3x is positive x. So I get x plus 4 equals 0, or x minus 3 equals 0. So I get x equals negative 4 or x equals 3. Now, hopefully you remember that when we got to a problem like this, we had a quadratic form problem with e to the x in the previous video. We had a situation where we had to check our answer. So let's go ahead and check. So when x is negative 4, I get log of negative 4 plus 2 plus log of negative 4 minus 1 equals 1. And the answer is log of negative 2 and log of negative 5 are undefined. You cannot take a logarithm of a negative number in the same way that an exponential cannot give you an answer that's a negative number. So I know that I can't have x equals negative 4. Let me grab another piece of paper and let's check x equals 3. So I've got log of 3 plus 2 plus log of 3 minus 1. Is that equal to 1? Okay, well, this is log of 5 plus log of 2. Now, if they're both logarithms, I can combine them and make it into a single logarithm, log of 5 times 2, over here on the left. So that's the log of 10. Now, what is log base 10 of 10? That's 1. Woohoo! So when x equals 3, it checks out. So our answer, x equals 3 and negative 4. And then I'm going to cross out the negative 4. So people know that this is, do you remember the name for this? This is an extraneous solution. So I want to keep that on the paper so people know you can come up with this answer, but it won't work. Because again, if you plug in -4, I know I got very small here, but you can't take the logarithm of a negative number. It just doesn't work. So, woohoo, yay! Okay, next up, good old Nancy. What does Nancy want to do, huh, squirrel? Now, squirrels know all about saving for the future. They don't always know where to find the nuts they've saved, but they know all about saving. So, Nancy wants to invest $4,000 in savings certificates that bear a whopping interest rate of 9.75% per year. And as I am recording this video, interest rates are nowhere near that high. They are for loans, but not for savings. Savings are significantly lower than that. So this is going to be compounded semi-annually. All of a sudden, we are thrown into a whole different world. So what's going on? So basically, this is going to be an investment. You're going to give probably a bank or a broker $4,000. And what they're going to do is semi-annually, so every half a year, they're going to calculate how much interest you've earned. And then they'll put the interest into the account along with the initial deposit. And the benefit of that is that your interest starts earning interest. And that's what compounding means. So the question is, how long a time period should she choose to save an amount of $5,000? Now, I'm guessing I copied this out of the book, and I hate the way this is phrased. But let's talk about what it means. So first thing, the good news is you don't have to know the formula. We're giving you the formula. Now, if you wanted to go into a business degree, you would need to know this formula. But for us, we're just going to get this formula for free. So this formula is given to us, and we just have to figure it out what's going on. So basically, the P, which is the principal, that's the money you start with. So your principal is what you start with. So in this case, the principal is $4,000. Woo! R is the interest rate. Okay, what's our interest rate? 9.75%, but it's supposed to be in decimal form. So since it's 9.75%, we have to rewrite it as 0.0975. Okay? N is the number of times you compound per year. Now, if it's semi-annual compounding, it means it happens every half a year or every 6 months. So in other words, it's going to be 2 times per year for the compounding. And other investments, for example, if you have a bank account or a credit card, compounding happens monthly. When they send you your statement, they tell you how much interest you've either earned or accrued if you're paying back a loan. T is the number of years. Now, in this awkwardly phrased problem, basically T is the thing we do not know. So T is our unknown. And then A is going to be 5,000. That's how much money we want at the end. Okay. And again, if you go into business, these words are all going to be very familiar. But if you're not in a business, pardon me, if you're not in a business major, then these may be new words, but these are going to be very similar to problems we've done about exponential growth. So this could be dollars or bacteria. Okay. So let's see what we can do about setting up this equation. So we've got this equation right here. I'm going to write it down again. A of t is the principal times 1 plus r divided by n to the nt. So we want 5,000 over here. We want 4,000 over here. 1 plus 0.0975 for our interest rate over 2 raised to the 2t. And this is our equation. And what we're going to do is we're going to solve for t. So how long will it take this investment to go from $4,000 to $5,000? So Nancy wants to earn an extra $1,000. So this is what you do. There are a lot of ways to approach it, but there's one way that's going to make it just so much easier than all the others. And the first step for this is to divide both sides by 4,000. Let's get that 4,000 out of the way. So I'm going to divide 5,000 by 4,000. So then over here, 5 divided by 4, it turns out it is nice, right? It's going to be, I think, 1.25. Now, what's really important is that if this does not work out nicely, do not approximate it. So if it's like 5 over 3, don't write out a decimal. Leave it as the fraction. It turns out here, 1.25 turns out nicely, so that's just nice. Okay, next thing. Up in here, 0.0975 divided by 2 gives us 0.04875. I'm going to add that to 1. And it's raised to the 2t. So you see the 4,000s cancel, and I calculate this divided by 2, and I get 0.04875, and I add it to 1. Okay, so first thing we check, is the base nice? And the answer is, well, it is if you're an investor. It's a really nice base because, wow, it's almost 10% a year. That is bonkers for earning. Even if you're really good at the stock market, only a few people can do that. And this is just a savings certificate. So this is really a great deal. So that's great. But in terms of numbers, that is not a great base. So we're going to choose a base. And I'm going to choose to use, because we used logarithm before, I'm going to use natural log this time. And instead of going into logarithmic form, I'm simply going to take the natural log of both sides. And I could use common log as well. And remember, the benefit of that is that this exponent comes down in front. Okay, let me grab a piece of grid paper so that I can keep going. Okay, so I'm going to copy it down onto the next page. Natural log of 1.25 equals 2t times the natural log of 1.04875. Okay, so then what? Well, at this point, it's important to remember, if you ever get confused, try to remember, what am I looking for? What am I solving for? And the answer is, I want the t. T is what I want. So since this is all multiplied together, I'm going to go ahead and divide out everything that I don't want on the right. So natural log of 1.25 all over 2 times natural log of 1.04875. So I'm dividing both sides by 2 times the natural log of this big ugly right here. So the 2 cancels, and the natural logs cancel. And all I have left over here is t, and then over here it's natural log of 1 point, oops, I got excited. should be 1.2, 1.25 all over 2 times the natural log of 1.04875. Now, this is the correct answer. This is the answer. That's the best you can do. And I know a lot of folks look at this and they go, wait, can we subtract these? And the answer is no. When there are 2 natural logs or any kind of logs, but they're dividing or multiplying, it doesn't work. It has to be 2 logs subtracting gives you the division, the ratio of the arguments. So this isn't quite that situation. This is the exact answer. And so the question is, what does this look like? Because we should, you know, if Nancy comes to you and says, hey, how many years should I leave this in? And you tell her that's the answer, she's going to pay someone else for advice. So let's go ahead and give her an actual answer. Hello, squirrel. So natural log of 1.25, close that. I'm going to hit enter. That's the numerator. That's just this part. And then I'm going to divide by 2 times natural log of 1.04875. And I get, let's see, T, and let's see, it's 2.343995 and some other stuff. So T is approximately 2.34 years. And if you want to get really, really fancy, what you do is you say, okay, that's 2 years. And then what I'm going to do is I subtract 2 from this answer. So I did a -2, and that gives me just the decimal part. And I multiply by 12. Why do I multiply by 12? It's 12 months in a year. And then it's going to tell me it's 4 and a bit. So it'll be about 2 years and 5 months. Why do I say not 4 months? Well, I'm rounding up. And then someone might point out, wait a minute, you can't take it out after 5 months. It actually happens semi-annually. It's about 2 years and 6 months. So it depends on the rules. Sometimes they say you can only take it out every 6 months, in which case we have to go here. If they'll let you take it out after 5 months and give you your interest, that's awesome. Okay, woohoo! There's a lot going on. As you can tell, business can be very complicated, but it's pretty cool. You can use exponential functions and logarithmic functions for that. And then, and I know it's been a long video, but we've got one more little itsy bitsy tiny little problem. I know, promises. The ones that the math teacher says will go really fast, they don't go really fast, do they? No, they don't. But let's give it a try, right? Squirrel is here for you. Yay! Okay. Suddenly this is an exponential problem. That's exciting. What's going on here? So I've got 2 times the quantity 7 plus 2 to the x plus 1 equals 100. What am I going to propose you do to solve this? Well, I would propose that what you want to do is you want to isolate the x, which means you want to isolate this thing, which means I'm going to divide both sides by 2. To get 7 plus 2 to the x plus 1 by itself. And then thoughts about what I'm going to do next? You got it. I'm going to subtract 7. And I'm going to say 2 to the x plus 1 equals 43. So why am I doing this example, this problem that we've already done? Well, there were some questions about problems like this, so I thought I would just tack this on to the end of this video so that I can give you an example. And once we're to this point, this is an exponential equation, but we're going to use logarithms. And again, since the base is 2 and I don't have a log base 2 on my calculator. Now, might you have a log base 2 on your calculator? Absolutely. If you have the TI 36X Pro, you have log base 2. You have log base anything you want. But in this calculator, I only have natural log or log. I'm going to use log because I just used natural log. So I'm going to take the log of 2 to the x plus 1, and that's equal to the log of 43 because logarithm is 1 to 1. And then the x plus 1 comes down in front. Then I'm going to divide both sides by log of 2. That cancels over here. And then I need one more piece of paper. So I'm going to rewrite this problem. I get x plus 1 equals log of 43 all over log of 2. And then I'm going to subtract 1. And I get x equals log of 43 all over log of 2 minus 1. Now, are there sneaky ways to make this pretty? Yes, definitely. There are ways to do this. This minus 1 I could make into a log of 2 over a log of 2. And then I could set up 2 logarithms and bring them together, and I can do all sorts of fancy things. For our purposes, I'm just going to leave it like this. But, you know, definitely talk to me because some people really, you know, they just enjoy playing with logarithms and rewriting things. There's lots of cool things you can do if you have infinite time, which I do not. So I'm going to quickly enter this into the calculator. I get log of 43 end parentheses divide by log of 2 end parentheses, and then I subtract 1. And I get x equals 4.426264, some other stuff. Or again, to 2 decimal places, 4.43. And remember, this is exact. This is an approximation. Woohoo! And we did it! Yay! You guys got through a very long, very complicated video. I am so proud of you. Please go take a rest, go take a break, get a snack, read, you know, dance, sing, draw, whatever it is you do that is fun, and go relax. Know that you're amazing and incredible, and I think you're amazing and incredible, and I hope that you have a great morning, day, afternoon, night, evening, whenever it is, and that your apocalypse is kind, that you're able to math on, and woohoo.